If you're a network engineer, you probably see the Session Border Controller, or SBC, as that reliable, but maybe a little boring box sitting at the edge of your network. Well, that box has quietly gone through a massive revolution. Today, we're going to trace its journey from a simple gatekeeper to a totally cloud-native, AI-powered brain that is fundamentally changing how we manage communications. All right, let's get into it.
So here's what we're going to cover. First, we'll start with a classic analogy that just perfectly nails the core job of an SBC. Then, we'll follow its evolution from a physical appliance into the cloud. We'll pop the hood and look at the new microservices architecture and get really specific on the security settings that actually matter. After that, we'll apply it all to a real-world Microsoft Teams integration, and finally, we'll look ahead to what AI automation really means for the future.
Okay, first things first. Before we jump into all the cool cloud native and AI stuff, let's get grounded in what an SBC actually does. And the best way to do that is with a really simple but powerful metaphor.
I just love this analogy because it's spot on. Seriously, picture your corporate network as this exclusive club. The SBC, it's that person standing right at the velvet rope, deciding who gets in, who gets kicked out, and making sure everything inside runs smoothly. Every single packet, every single call, it has to get past the bouncer first.
So what's this bouncer's job description? Well, it maps directly to the SBC's main functions. First, it checks IDs, verifying where all the traffic is coming from and where it's trying to go. Next, it enforces the house rules by applying security policies. It also manages capacity, making sure the club doesn't get so crowded that the whole network crashes. And maybe, most importantly, it's a mediator, kind of like a universal translator, making sure a phone system from one company can actually talk to a video client from a totally different one.
For the longest time, that bouncer was just a single physical box humming away in a rack. But the club, our global communications network, it changed dramatically. And so, the bouncer had to change too. It had to evolve from just a piece of hardware into this dynamic force that actually lives in the cloud.
Well, the pressure to evolve was just immense. I mean, think about the rise of remote work, where the edge of the network is suddenly everywhere, or the absolute explosion of services like voice over 5G, which brought a scale we'd never seen before. All of a sudden, a static physical box with a fixed capacity was like having just one bouncer for a stadium of 100,000 people. It just couldn't keep up. It was never going to scale.
And this image right here, it captures that whole architectural journey perfectly. We started with the PNF, the physical network function. That's our classic hardware box. Then, we got a little more flexible and virtualized it into a VNF, putting that same software onto a virtual machine. But the real game changer, the big leap, is the CNF, the cloud-native network function. This wasn't just a tweak. It was a complete redesign of the SBC from the ground up, built specifically for the cloud era.
So the huge shift here is from a monolithic design to a microservices architecture. The old SBC was just one giant tangled block of code. If you wanted to update one little feature, you had to reboot the entire thing. The new cloud-native SBC, though, is broken down into dozens of small, independent services. And what that means is you can update one part, or scale one part, or even have one part fail without taking down the whole system. That right there is the key to resilience and agility.
Okay, so if the modern SBC is made of all these tiny little independent services, what's stopping it from just becoming total chaos? Well, that brings us to the engine that runs the whole show, a combination of microservices and an orchestrator like Kubernetes.
Let's try another analogy here. If each microservice, like one for call routing or another for media processing, is a chef in a huge kitchen, then Kubernetes is the head chef or the restaurant manager. It's constantly watching the demand. A massive order comes in, boom, it instantly spins up 10 more chefs to handle it. And when the rush is over, it sends them home. For our SBC, this means it can elastically scale resources up and down in real time, matching the demand perfectly.
And hey, this isn't just some theory. Look at this number from Nokia. They can scale to handle the traffic from 3 million mobile subscribers instantly. So what does that really mean for you as a user? It means that when a big storm hits and everyone picks up their phone at once, the network doesn't just collapse. Your call goes through. That kind of reliability is a direct result of this cloud-native architecture.
This new architecture isn't just about scale, it's also about much, much smarter security. The bouncer isn't just some big guy at the door anymore. It's a high-tech security system with multiple layers of defense. So let's get into the specifics of what engineers actually need to configure.
Real, full security starts with encryption, and you have to protect two different things. Think of it like a classified letter.
TLS encrypts the envelope. It protects the signaling, so nobody knows who called whom. But you also need SRTP to encrypt the letter inside that envelope, the actual audio and video of your conversation. An attacker could grab one without the other, so you absolutely positively need both for a truly secure line.
But beyond encryption, it's all about defense in depth. At the lowest levels, you've got packet filtering to block those brute force network attacks. Move up the stack a bit, and you have SIP-aware firewalls that are actually inspecting the call commands for malicious code. Then you add things like topology hiding, so attackers can't even map out your internal network. Plus, powerful defenses against those nasty denial-of-service attacks. Each layer is designed to stop a different kind of threat.
Okay, theory is great, but let's make this real. Let's ground all this in one of the most common projects a communications engineer has today, connecting your phone system to Microsoft Teams using a cloud-native SBC.
So what exactly is direct routing? In short, it's Microsoft's way of letting you bring your own carrier to Teams. So instead of buying all your calling plans from Microsoft, you use an SBC to connect Teams to whatever carrier you want. And the benefit? Control. Total control. You get to keep your existing phone numbers, you can use specialized international carriers, and you can build complex, resilient call routing that you manage yourself.
Now, for any engineer who's been tasked with this slide right here, this is your Bible. Every single point is critical. You absolutely need a certified SBC because Microsoft has already tested it. You need a public certificate so Microsoft servers know they're talking to a legitimate device. Mutual TLS is required because that trust has to go both ways. Your SBC also has to verify Microsoft's identity. And finally, SRTP is totally non-negotiable for securing the media. Miss even one of these, and it simply will not work.
We've seen the whole journey now, from a physical box to this dynamic, cloud-native system. But you know what? There's one more leap to take. Infusing this entire system with AI to create networks that aren't just automated, but are truly intelligent.
Just take a look at what the major vendors are building right now. They're creating these incredibly sophisticated management layers that sit right on top of the SBC. You've got Ribbon integrating generative AI for intelligent analysis. Oracle is building auto-healing capabilities using popular open-source tools. And Nokia is focusing on fully automating the entire software lifecycle. The trend here is crystal clear. The industry is moving from manual operation to intelligent orchestration.
And the ultimate endgame for all this tech is the self-healing network. We're moving way beyond just getting an alert when something breaks. The goal is a system where AI analytics can spot the faint, early signals of a future failure or an emerging security threat, and then automatically take corrective action, rerouting traffic, scaling up resources, blocking a threat, often before a human engineer even knows there's a problem.
So this entire evolution brings us to a really, really crucial question. We've traced the SBC from a box you configured with a command line all the way to an automated self-healing system run by AI. So if the AI is handling the day-to-day operations, what does the job of the network engineer become? The focus has to shift. It's no longer about hands-on configuration. It's about becoming the architect, the designer, and the trainer of these intelligent systems. It's a profound change for sure, and it's happening right now.